welcome back to the Algebra 2 PLC and this series of videos that we're making to talk through the SLTs. And on this one, we're going to be focusing on SLT 24. I'm John Chase.
And I'm James Key. Let's go ahead and dig into SLT 24. In this SLT, students are using algebra to reveal the key features of the graph of a rational expression like the one you see here. It might not be that obvious to students what the graph of this equation looks like, whether it has a similar appearance to the graph of the one that's familiar now. Does it look like this one? Does it look like this one? Or does it look like something completely different? And since students will have experienced the fact that there are horizontal and vertical asymptotes, the question arises as to where might those come up and how can we be sure where they are? So with that, let me just, before we actually jump into this problem, let me highlight a shift in instruction. Having looked at the material in this blue and green text that's been in use, I noticed that this form was presented after an example that's a more typical transformation of 1 over x. They hit readers with this linear divided by linear, and then it follows with the statement, the horizontal asymptote is the line y equals a divided by c. And they offer absolutely no explanation for that statement whatsoever. There's no activity for students to explore or discover or investigate or unpack. In other words, they're presenting students with the what without telling them why or how, let alone letting them discover why or how. So John, how could you determine where the asymptotes are given that the expression is presented in this form? Could you show us?
Yeah, that's a great question. So let's actually go back to that first example and dive in. Let's do it right now in front of everybody. So in that original expression, we have 2x minus 9 divided by x minus 5. And it's worth pausing as we say that to hear what we just said. It's 2x minus 9 divided by x minus 5. And so students might not be thinking about that as they look at this expression, that this is a division problem. And so therefore, maybe we can use the techniques we've just been speaking about earlier in our topic 2. So let's do the division. I'm going to choose to do 2x minus 9 divided by x minus 5 using long division. Though, we also have been reacquainted with some other techniques that include the box method or partial quotients. So choose your method. We should all get the same answer in the end. X into 2x goes 2 times. Multiplying that out gives us 2x minus 10. And subtracting gives a positive 1 as the remainder. And a lot of people would just kind of stop there and be like, done. But we actually want to say what we've just done. We've just said, in essence, that the original expression 2x minus 9 divided by x minus 5 is equal to 2 plus 1 over x minus 5. That's in fact what we have just said.
It is indeed. And having done that algebra, I'm wondering, is there any use for that? Did we just move the symbols around just for the fun of it? Well, let's go into graphing mode here, and let's see the usefulness of doing that algebraic manipulation.
Absolutely.
All right, let's go ahead and take a look here. So the original expression for f of x is presented here at the top, and then John, having done that long division, produced a quotient and a remainder here. And so as we look at that, we can see that something interesting must happen when x is 5, all right, and comparing it to the parent function, g of x equals 1 over x. We know that when x is close to 0, g of x gets really, really large. And so that's why we saw a vertical asymptote for that graph at x equals 0. This graph, however, has an interesting feature at the value of x that makes x minus 5 equal to 0, which of course would be x equals 5. So one thing that becomes evident on this is that the vertical asymptote occurs along the line x equals 5. The other thing we can see from this transformed expression is that if x is a really large number, way far out on the right end of the number line, then we're going to get 1 divided by a large number, which is going to be close to 0. So when x is large, this expression is close to 0. And then when you add 2, the result will be close to 2. So all that is to say the horizontal asymptote should occur at the line y equals 2. Other than that, this really just is a transformation of 1 over x, and so the graph has a similar appearance to the graph of the parent function.
And I think it's worth stepping our students through that process to reveal why, like you said, the why, not just the what. Why is it 2 over 1 is maybe the kind of the textbook way of doing it. It's 2 divided by 1. Just memorize that. But let's think about why that happens, and I think we've just done that, and we should try to do that with our students.
Absolutely. Okay, as we maintain a focus on standards, let's go ahead and look at the domain around arithmetic with polynomial and rational expressions. And clearly the focus of this SLT is right here. There's actually a cluster of standards around rewriting rational expressions. And so the standard reads, rewrite simple rational expressions in different forms. In particular, write an expression a over b in the form q plus r over b, and that's exactly what John did. In this case, we highlighted the technique of long division, and the result of that was we were able to analyze some key features of the graph. We hope that this overview of SLT 24 was helpful to you. We hope that you'll stay tuned for our next segment, which is around SLT 25. Thanks for joining us.